A company has 1,825 employees. The employees are classified as professional, skilled, or elementary. The following table shows the number of employees in each classification, the two areas A or B where the employees live. An employee is chosen at random. Find the probability that this employee is skilled and lives in area B and is not a professional. Now it helps to have the totals around the table. We know that this is 1825 and the other totals will be 1275, 550, 340, 365 and 1120. Probability of being skilled is going to be 365, that's the total for the skilled employees, out of the total 1825. Lives in area B and is not a professional is going to be these people just here, and so that is going to be 170 out of 1825. Some classifications of employees are more likely to work from home. 65% of professional employees in both Area A and Area B work from home. So we can see home is here. And we're told that F is the professional employees. So 65% of the professionals work from home. They should be in this space just here. So we have 1,120 employees who are professional. So if we do 0.65, 65%, times 1120, that should give us the total in the area that I've shaded yellow. But of course, we've got 247 already in there. So if we take away the 247, that gives us 481 in this middle section. Now note that R is the people from area A. So anything outside of that circle will be area B. So we know that the F is the professional employees, and we can see from our table up here that there's 1,120 of those. We've only got one section left to fill there, and so if we do 1,120, take away the 481, take away the 247, take away the 133, we end up with 259 in that part just there. And this section is the work from home. And the total number of employees that work from home is going to be 0.65 times the 1120. That was for the professionals. And then 40% of the skilled. So that's 40% of the 365. And then 5% of the elementaries, which is 340. And if we calculate that, that comes to 891. All we need to do then is subtract from that the other values that are in that circle, and we end up with 40 in here. Now we know in total that there were 1825. If we do 1825, take away all the other numbers, we'll end up with 130 in the outside. So now that we have the Venn diagram, we have some probabilities to do. The probability not R, so that's outside of R, and F, so inside F but outside of R. Well, the values that are in F and outside of R are these two values here. So that's going to be 247. Add 133 divided by 1825. And that gives us 0.2082, correct to 4 decimal places. Now in E, we want the probability of not H union R. So let's look at the number of things in H union R. So if we think about H union R, we're talking about these values just here. So that is going to be 40 plus 123 plus 412 plus 247 plus 481 plus 259, and that gives us 1562. So the probability we're after here, where it's not that, is going to be the total, take away 1562, divided by 1825, and that is 0.1441 to 4 decimal places. Finally, we have the probability of F given H, which is going to be the probability of F and H divided by the probability of H. So F and H is going to be these values just here. So that is going to be 247 and 481, and we need to divide that by the number of things in H in total. So we need to add these two values in. So that is going to be 247, add 481, add 40, add 123, and that is 728 over 891, which is approximately 0.8171. We're giving that to 4 decimal places, so we could put equals to 4 decimal places.